Good morning, developers. If you are new to the channel, my name is Rob and it is CS Thursday. We typically don't code. Instead, we are trying to figure out how things work, computer architecture, programming languages. And today we're going to look at what is the microtask queue and the callback priority in JavaScript. Now, I know those may sound like really scary terms, especially the first one if you don't know what it is. It is not that complicated. Give me a second to explain. It is worth it if you're a JavaScript person. This comes from a longer video. So the microtask queue I covered in another video on the JavaScript event loop. If this whets your appetite, I'll drop that link in the description, but it's worth covering on its own. Let's say you have a file and you have at the top const x equals 3, and then you have, I don't know, another variable, const y equals an array, and then you have a loop. And this is not valid JavaScript, so please don't think of it that way. We're going to loop like 1,000,000 times. And then you have a click listener. You've got a dot on click. And if that happens, you're going to run a callback like so. And then down below here, we're going to make a fetch request. So we've got an await right here that is going to block. And I'll just put await fetch. And then down here, we've got another loop 1,000,000 times or whatever. Okay, so how does JavaScript decide what order to run the code in? That is what the event loop's job is. The runtime, which is going to be the browser or Node.js, has a JavaScript engine, which is going to be SpiderMonkey or V8 or something like that. And the event loop runs just like a loop. It is constantly iterating. Each iteration, it grabs one line of code and then it starts over. And for this particular case, it will grab this line first, right? The first synchronous line that it can run. I don't have to wait to do this. I'm going to run this line. So that one's done. And then it goes to the next line, the next iteration. Okay, I've done that one. I'm done. Okay, and then it runs that. Now that's going to take 1,000,000 iterations to run. So we've got 1,000,000 loops, but once it's finished with that, it is done. It gets to this one, we got a little problem here because this part, that can be run. That actually is handed off to the runtime, so that the browser, you can't click in Node.js, but the browser web API will notice, oh, okay, I'm supposed to listen for a click. This other part though, this callback, that cannot be run until that thing happens. So what happens? Well, we'll come back to that. The next thing, we've got another await, and that's the same thing here where the fetch can run right now, but it is going to block the rest of the code below because that await is there. So we've got these two things that happen, right? This one, when we get there, it'll be able to run synchronously, but we're not there yet. How do we get there? And again, how does JavaScript make this decision? Well, as we process all the synchronous lines and all the function calls and so on, whenever a callback is encountered, so this dot on click, that callback, up until 2015, there was only one bucket, and it is called the queue. And so all of the callbacks that have not been run but are known about and are going to be run, they are put in the queue. And they are arranged from oldest to newest. And when the time comes, when there's no more synchronous code to run, right? So this constant, we've looped 1,000,000 times, we've got our callback, we've got our await, we are now stuck. There's no more synchronous code to run. So JavaScript will, the runtime or the engine will go to the queue and see what is the oldest thing in the queue that can be run right now. It will grab that thing and it will go run it. It actually puts it onto the stack. We're not going to talk about the stack here. But it will keep doing that and running the code in the callbacks based on the order that they came. Well, in 2015, when promises were added, await wasn't added until the following year, but when promises were added, it became a little bit of we need to update this because there is a priority now for callbacks is that there's not only the regular callback queue, I'm going to put CB here, there's a callback queue, there is also now a microtask queue. And the microtask queue is going to hold all those callbacks that are related to a promise. So in this case, we've got an await fetch. We cannot move on. Now, you can't see the callback here because await is hiding it, but we cannot move forward until this fetch is finished. Once that fetch is finished, then we move forward. So that one, because it is promise related, is going to get put into this microtask queue. This callback, it's not related to a promise, so it's going to get put into the standard callback queue. once all of the synchronous code is finished. Okay, so again, we did this line, we did this line, we did this line, we added the listener, but we're waiting for the callback and we're waiting for this fetch to finish. It is ready to go check the queue. The first queue that it will check is the microtask queue. That can give you priority if you know that this thing needs to be done first or has a higher priority than all of the other callbacks in your code. You use promises. The promise queue or the microtask queue gets executed first. This will get pulled out and put onto the stack. Once that is empty, right, oldest to newest, once this is empty, then it will move on to the regular callback loop. This has a big advantage because JavaScript is blocked right here, right? If these are both ready to run at the same time, the click and the await, if that's unlikely, but if they happened at exactly the same time, this one is blocking synchronous code. This is ready to go, but it cannot go until that is finished. So it is a way to prioritize your code. Let's get the promise stuff done first, and we can move on if there's blocking code. Once those are done, we can go back and handle the events, the callbacks that happen after a set timeout or a disk write or a database read or something like that. That is what the microtask queue is. It's important to know because your promise-related callbacks have a higher priority than all of the other callbacks in your code. That's how the microtask queue works. That's why it was added back in 2015. Write promises, use it, and thanks for watching another CS Thursday video. I will see you next time.